Welcome back, students. Let's use what we learned in the last video about exponents to try to solve some equations where the variable is in the exponent. Number one here you can probably do in your head. Can you think of an exponent that would take 6 and change it into 36? Surely this is going to be a 2 because 6 squared is 36. But if you couldn't do it in your head, and you know there are problems coming soon that you can't do in your head, here's the way I would do it. Let's rewrite this problem. This problem is not about the number 36. It's about the number 6. I could rewrite 36 as 6 to the second power. Let's copy the 6 to the x here. Now, in order for this to be an equation, everything on this side must equal everything on this side. And since these bases of 6 already equal, the only way for this to be an equation is for these exponents to be equal. Let's circle that up. What did we do? We changed the equation so that they both had a base of 6. If they both have a base of 6, then their exponents must be equal. For example 2, I don't think I can do this one in my head. I can't think of a number that I can use as an exponent that changes 64 into 16. That's very difficult. So let's use our trick over here of changing numbers into smaller numbers with exponents. You see, this problem is not about the number 16, and it's not about the number 64. It's about the number 4, because 4 squared is 16. I can rewrite 16 as 4 squared. And 64 is 4 to the third power. I can rewrite 64 as 4 to the third power. So instead of 64 to the x power, I have 4 cubed to the x power. And instead of 16, I have 4 to the second power. My goal, to get these bases to be equal to each other. And if the bases are equal to each other, then the exponents must be equal to each other. What are the exponents? This one's a 2. And when you take a power to a power, you multiply the exponents and then get x by itself by dividing by 3. X must be 2/3. What did we do? We rewrote 16 as a base of 4. 16 is 4 squared. We rewrote 64 with a base of 4. 64 is 4 cubed. Then if the bases are equal, the exponents must be equal. The exponents being 3 times x and 2. Let's try another. See, now when I look at number 3, this problem is not about the number 81 or about the number 9. It's about the number 3. 9 is 3 to the second power, and 81 is 3 to the fourth power. Let's rewrite this problem using bases of 3. 81 is 3 to the fourth power, and 9 is 3 to the second power. Now, if these bases are equal to each other, then these exponents can now be equal to each other. The exponent here is 4. The exponent here, if I take a power to a power, I must multiply. So distribute 2 times 2x and 2 times 1. 2 times 2x and 2 times 1. Now we'll solve. Subtract 2 from each side. Divide by 4. 2 over 4 reduces to 1/2. What did we do? We rewrote 81 and 9 as bases of 3. 81 is 3 to the fourth power. 9 is 3 to the second power. If the bases are equal, then the exponents are equal. So the exponent of 4 must be equal to the exponent of 2 times 2x and 2 times 1, 4x plus 2. Let's try it again. This would be a very hard equation unless we use our trick. You see, this problem is not about the number 1/4. It's about the number 2. Let's keep the 2. Can I rewrite 1/4 as 2 to some power? Look at my bases of 2. Well, I know that 1/4 is 2 to the negative 2 power. 1/4 is the reciprocal of 2 squared. 1/4 is 2 to the negative 2 power. Now, if the bases are equal, then the exponents are equal. My exponents are 3x and negative 2. And then solve for x. When you work these problems on your assignment, I want you to write the equation down and then show the work as I'm showing the work. Don't just write the equation down and the answer. That doesn't get you full credit.